Sulfur dioxide. Preparation. Sulfur dioxide can be easily prepared by burning sulfur in air. The reaction involved is sulfur plus oxygen gives SO2. In laboratory, it can be easily prepared by reaction of sodium sulfite with hydrochloric acid. The reaction involved is sodium sulfite Na2SO3 plus HCl gives sodium chloride plus H2O plus SO2. Now, sulfur dioxide gas has a pungent suffocating odor. It is colorless gas. It acts as Lewis base due to presence of lone pair of electrons. Already we know that the structure of sulfur dioxide is a resonance hybrid of two canonical structure. The molecule is bent having sp2 hybridization and it has got a lone pair. Now this lone pair is responsible for Lewis base character. Now the sulfur dioxide gas is soluble in water. Now because of its solubility, it is acidic in nature. It dissolves in water forming sulfurous acid, that is SO2 plus H2O forms H2SO3. Now sulfur dioxide is oxide of a non-metal, so it is acidic in nature, and acidic oxide reacts with base forming salt and water. So the next reaction is NaOH plus SO2 gives Na2SO3 plus H2O, that is sodium hydroxide reacts with sulfur dioxide forming sodium sulfide plus H2O. Now sulfur dioxide also shows reducing nature. In presence of moisture, it can liberate nascent hydrogen, or in presence of an oxidizing agent, it can easily take a oxygen atom and show the reducing nature. Now, sulfur dioxide reacts with nitric acid forming sulfuric acid and nitrogen dioxide. Now, in this reaction, we will see that sulfur dioxide is oxidized to H2SO4 because its oxidation number has increased, and nitric acid is reduced to NO2 because the oxidation number of nitrogen is reduced from +5 to +4. Now second reaction, we can see sulfur dioxide reacts with ferric chloride in presence of an acidic medium, or in presence of moisture. We will see that the ferric chloride is converted to ferrous chloride plus H2SO4 plus HCl. Now here again we see that the ferric ions are converted to ferrous ions. Now third reaction, again we see when sulfur dioxide gas is passed through acidified KMnO4 solution. Now KMnO4 solution is pink in color. When SO2 gas is passed, the color of the solution disappears, that is the color is discharged. Now this particular reaction is used to detect the presence of SO2. Now the reaction involved is SO2 plus KMnO4 in presence of H2SO4 forms K2SO4 plus MnSO4 plus H2, that is acidic medium is required for this particular process. Now during the process, the +7 oxidation state of Mn gets converted to +2 oxidation state, that is why the color is discharged. Now the last reaction, we see that SO2 reacts with potassium dichromate in acidic medium. Now potassium dichromate is orange colored substance. It is orange colored solution. When SO2 gas is passed, the orange colored potassium dichromate gets converted to green colored chromium sulfate. Now again in this reaction also we see that the chromium oxidation number in potassium dichromate is +6, gets converted to +3 in chromium sulfate. So here the reducing behavior or reducing nature of sulfur dioxide is exhibited. These four reactions explain the reducing nature of sulfur dioxide. Now sulfur dioxide also shows oxidizing nature. Now we will see that sulfur has got the intermediate oxidation state of +4 in SO2. So it exhibits reducing properties as well as oxidizing properties. Now we can see here in the reaction, sulfur dioxide reacts with H2S, that is hydrogen sulfide, forming H2O plus elemental sulfur. Now in this reaction we see that the sulfide ions are converted into sulfur. So sulfide ions are oxidized because the oxidation number of sulfur in H2S is -2. It gets converted to elemental sulfur where oxidation number is 0. So here we see that SO2 is exhibiting oxidizing nature. Another reaction where we see the oxidizing nature is when sulfur dioxide reacts with carbon monoxide, it forms carbon dioxide plus elemental sulfur. Again here carbon monoxide is oxidized to CO2. So sulfur dioxide shows oxidizing behavior also. Now, apart from reduction and oxidation, sulfur dioxide also shows bleaching nature. Bleaching means ability to convert colored substance to colorless one. So we will see that sulfur dioxide acts as bleaching agent, but this particular property is shown only in presence of moisture, because in presence of moisture nascent hydrogen will be released. So we will see that it is in this process, there is the liberation of nascent hydrogen, which brings about the bleaching. We can see here the sulfur dioxide reacts with water, forming sulfuric acid and two nascent hydrogen. Now, these nascent hydrogen combine with coloring matter to form colorless compound. Now, one thing is to be kept in mind that the colored compound gets converted into colorless compound. Now bleaching due to SO2 is temporary. The moment you take out the substance in the air, again the color is redeveloped. So we will see that the bleaching due to SO2 is temporary.